We've used trigonometry rules in order to find side lengths. Okay, and today we're going to look at the properties of the triangle that allow it to also help us to find theta or the angle. So we're talking over and over about these properties of the right angle triangle that make it fit so that we can use these rules that we have looked at in order to figure out different things. But side lengths is one thing, but now we're looking at angles. The tricky thing about the angles is that this theta, which represents the angles, is kind of joined to our actual rule, and the only way we can get rid of it is to use what's called inverse trigonometry rules, okay? We can't simply move the sine or the cos or the tan to the other side of the equation without changing it first. It's a little bit like algebra, but we also have to consider how special these rules are. And what you'll see is the inverse rules are written in a very similar way to the normal rules, except what happens is that if we change it to our inverse so we can get theta on its own, so we can calculate how big the angle is, we have theta will equal inverse sine. And the inverse sine will have the little -1 at the top. We don't say -1, we say inverse sine. And then it's exactly the same. So to find the angle for all of these different rules, we just do exactly the same thing. But on our calculators, we have to generally click like second function or something in order to get the inverse. So the inverse of cos to find the angle would be inverse cos adjacent on hypotenuse. And the exact same thing goes for tan. If we want to find the angle, we have to use our inverse rules.